Happy Monday! Today we are talking about hydrates. Hydrates are really cool because we use them all the time without realizing that we're using them. Hydrates are a compound which contains water. An example of this would be copper 2 sulfate pentahydrate. A dot connects the molecular formula of water to the molecular formula of the hydrate. Between the dot and the water will be a number representing the number of water molecules per hydrate molecule. So there are going to be 5 water molecules for each molecule of copper 2 sulfate in this sample. We can find the percent of water in a hydrate similarly to how we find percent composition. We divide the mass of the water by the total mass of the hydrate. This means the mass of the water plus the mass of the molecular formula. Then multiply by 100. Here's our first example. We're going to calculate the percent by mass of water in washing soda, something very similar to baking soda. The chemical name is sodium carbonate decahydrate. We can use our knowledge of ionic naming to identify the molecular formula of this molecule. Pause the video and do that. All right, let's check to see what you got. Sodium is Na. We know from the periodic table that sodium will have a positive 1 charge. Carbonate is one of our polyatomic ions. We can look this up and find it as CO3. It has a charge of -2. In order to make this molecule happy, we need to add a subscript of 2 onto the sodium to balance it out. Therefore, we have Na2CO3 as the first part of our hydrate. We need to add our dot and our water molecule. Now we need to identify how many water molecules we have per each molecule of sodium carbonate. We use the prefix deca here to identify what that is. Deca means 10, so we will have 10 water molecules per each molecule of sodium carbonate. Now for the math. We have to take the amount of water and find the mass. We can calculate the molar mass of water to be 18.016 grams per mole. We have 10 molecules of water. Therefore, we need to multiply this number by 10 and get 180.16 grams per mole. This will go at the top of our formula. Now to find the mass of the sodium carbonate. We simply add together the mass of 2 sodiums, 1 carbon, and 3 oxygens. This will give us 105.99 grams per mole. To find the molar mass of the entire hydrate, we have to add our 180.16 from our water. This will give us 286.15. grams per mole. This is the amount that goes on the bottom. Note that our units cancel, and this will give us 0.630. We multiply this by 100 to get a percent, and this is our percent of water in sodium carbonate decahydrate. To review our steps, the first thing we did was find the mass of water. We did this by calculating the molar mass of one molecule of water, which was 18.016, and then multiplying that by the 10 water molecules we had. Next, we found the molar mass of the hydrate by adding the molar mass of sodium carbonate to the mass of the water that we found. Lastly, we divided the mass of water by the mass of the hydrate and multiplied it by 100 in order to get a percentage. Here's a second example. We need to calculate the percent by mass of water in copper 2 sulfate, pentahydrate. Again, using your knowledge of nomenclature, identify what you think the name or the molecular formula of this compound is going to be. Pause the video while you do that. All right, let's check to see if you got it right. The symbol for copper is Cu. This Roman numeral of 2 tells us the charge of copper will be positive 2. Sulfate is a polyatomic ion that we can look up in our list. This is SO4. On that list, we can also see that the charge for SO4 is negative 2. Therefore, copper and sulfate balance one another out, and they are happy. We will add a dot and H2O for our water. Now we use our prefix penta to identify we will have 5 water molecules per each copper 2 sulfate molecule. At this point, pause the video and find the percent by mass of water in copper 2 sulfate pentahydrate. Let's check your answer. Remember that the mass of water is going to be 18.016 grams per mole. We have 5 water molecules in this example, so we will multiply by 5. This will give us 90.08 grams per mole. Because this is water, we will put this at the top. Next, we have to identify our mass of copper sulfate. The molar mass of copper sulfate should be 159.62. This again is grams per mole. We need to add the 90.08 that we found for our water to get the total amount for the hydrate. This will give us 249.7 grams per mole. This is our total hydrate mass, and it will go on the bottom. Again, our units will cancel out, and the number we get there should be 0.361. We multiply by 100 to get a percent. And in this example, we have 36.1% of water.